Okay, hello. So this is going through the homework questions. So this first question is about a cricketer bowling a ball from a height of 2.3 metres. And it says the ball leaves the hand horizontally with a velocity u. Now, the important thing to remember here is that as it's going along horizontally, the speed's not going to change, the velocity is not going to change, because there's no acceleration in that direction. Gravity acts downwards, not horizontally. So whatever speed the ball leaves with at the start, it finishes with at the end, horizontally. But vertically, the initial vertical speed is 0, it's not moving down, and it gets faster and faster and faster downwards, it's accelerated by gravity. So that's what they're asking us to work out here. So if we just do our little SUVAT, so I'm going to shift this up a little bit, SUVAT, pop this on here, and what we're going to actually do is we're going to consider something that's being dropped effectively from rest through 2.3 metres. Let's see what happens. So S is 2.3. The initial vertical velocity is 0. The final vertical velocity, we don't know. The acceleration, minus 9.81 meters per second squared. And the time it takes, well, we're trying to show that it equals something that rounds to 0.7 seconds. So just looking at this, this is the T, S, U, A, T. We're going to use S equals UT plus half AT squared. But the UT doesn't matter because the U is 0. So it becomes S equals half AT squared, and we want to find out T. So T is 2S over A. 2S over A, but you've got to remember to find the square root of that. And I think that comes to 0.68 seconds. And that's that one. Next one is working out the time to rise. Now, they've put this as being worth 3 marks, so it's a little bit more challenging. And the reason why this is a little bit more challenging is something that catches people out sometimes, and that's this time after the bounce, it has been going down quite quickly, and then it bounces and it sets off vertically with a large velocity that's going to get less and less and less and less until at the top of the bounce the vertical component of the velocity is going to be 0. So V equals 0 and U equals, well, we don't know what U equals. So that's what throws in our additional challenge here. So probably the best way of approaching it, or the way that I approached it, was to try and find out what this initial speed was. So we're going to do that first of all, and once we've got that initial speed, we can go on to use another equation to find out how long that took. So we'll do that down here. So we want to find out how long it takes to get to the top. So I'm going to use V squared equals U squared plus 2AS. Right, so V squared, the speed it's going at the top, is going to be 0. That's going to equal U squared plus 2 times minus 9.81 times the height that it's bouncing, and the question tells us it bounces 0.71 meters, so times 0.71. And when you solve that, which I'll let you do, we get that u equals 3.73 meters per second. Now we know that speed, we know the initial speed, whoops, that's off the screen, sorry, the initial speed, the final speed, and we know the acceleration, so we could use v equals u plus at to find out the time. And if we use that, we've got that the final velocity is 0 equals 3.73 plus minus 9.81 times t. And the t comes out at 0.38 seconds. But I think you need to confirm that. Okay, the next part of the question, part C, says to use the parts A and B to calculate the initial horizontal velocity. Now, this is where you have to remember that the horizontal velocity has remained constant. So whatever u is here, it's going to be the same over here. And from the previous two parts of the question, we know that it's taken until it bounces. I think it took 0.68 seconds, yeah, 0.68 seconds, and then to rise back up again took a further 0.38 seconds. And suddenly this makes this really, really easy, doesn't it? So we know how long it took, and we know how far it's gone, and it's not been accelerated. So we're just going to, and I'll move over here, we're going to use speed. Is that what they're asking us? Yeah, speed equals distance over time. And the s is the 20 meters, and the time is the sum of the two parts from the earlier part in the question. So that's 20 meters over 0.68 plus 0.38. And the velocity comes out at 18.86 meters per second. And why wouldn't it have been constant? Well, a couple of reasons. Air resistance would be one. Another one is that this is going to be an inelastic collision, i.e. some of the kinetic energy has not been conserved, so there's probably been sound, there's probably been some transferred to heat, which means it hasn't bounced as high as it initially came from. So some energy has been lost there. But to be honest, I'd probably just go with air resistance. Okay, the next question was about this flea jumping, and it jumps 0.44, well, it doesn't jump, but it accelerates over a distance of 0.44 millimeters, and it tells you its speed. And the first question we can't do, because we haven't done that yet. Next thing, let's look at the next question. At the moment the flea's leg leaves the surface, its body is raised 0.44 millimeters, and it's moving at a speed of 0.95 meters per second. It would have started at rest. So we can use our SUVAT. I'll do it over here actually. SUVAT. So moving at a speed, so that's the final speed, 0.95. Okay, I'll put the units. The S, 0.44, but that's millimeters, so we'll just put times 10 to the minus 3 meters. The initial velocity is going to be 0, a minus 9.81 meters per second squared, and it doesn't tell us anything about time. Just going to focus that. Okay, so SUVA, no t, that's telling us to use v squared equals u squared plus 2as. So what do we do next? Substitute everything in there, and it comes out that the acceleration equals 1026 meters per second squared. I'm not done the working out. You need to check that you can do that. Next question would just be using F equals ma, but technically we've not done that yet, so I'm going to skip it. What constant force opposes the upward motion? Its weight. I expect most of you would have put gravity. That would be okay as well, but it's better to say weight. And then the next one is where it gets a little bit strange. It says air resistance also opposes the motion of the flea. So you've got, that's my little flea drawing. We've got gravity or weight opposing its motion, and that would try and make it accelerate downwards at minus 9.81 meters per second. But we've also got air resistance or drag acting on it. So both of those forces acting downwards would mean that the acceleration is different from minus 9.81. But they have told us it's constant. So what they're telling us is that we can use SUVAT equations, but we can't assume that the acceleration is minus 9.81. So I'll go SUVAT. We want to calculate the change in the height. So I'll put a question mark there. We know that initial velocity is 0, final velocity 0.95. Acceleration, we don't know. And the t is 9.3 times 10 to the minus 2 seconds. So when I initially did this, I did it a very complicated way. It turns out that there is an easy way of doing this. I just didn't really think straight. We're just going to use the equation v plus u over 2 I've just done that wrong. Written it down wrong. There you go. So the average velocity times the time tells you the distance travelled, and it comes out at 0.442. There you go. That question has been my nemesis. Right, let's have a look at the final question. Okay, the first question about this golf ball falling from rest from a window of a tall building. They assume the acceleration is constant. Is it reasonable? And you can say yes. Whoops. Or you can say no. Both are correct. Yes, because air resistance is negligible. Or no, because air resistance becomes significant. Either are fine. Okay, and now we get to a spreadsheet. Now, many of you won't have used spreadsheets very much. Generally, when they turn up in exams, they're just trying to get you to explain what's going on. So what's worth doing in this is indicating what each thing represents. So in this case, this would be our t, velocity reached, v, and distance fallen and total distance fallen. Sorry, I had a phone call. Distance fallen and total distance fallen can either be, both of those might be some kind of S depending on the context. So let's see what we've actually done here. B6 equals 9.81 times A6. That's basically saying B6 velocity reached, so V equals A t. So why it's appropriate is that they've used v equals u plus at, and the u is 0 because it's done from rest. Okay, next part of the question. Cell C7 is calculated using the so-and-so formula. Explain what B6 plus B7 over 2 represents. So let's have a look at B6 and B7. So B6 is this number here, and then B7 is the speed that it's reached 0.2 seconds later. So adding them together and dividing them by 2 is finding the average speed over that interval. So it represents the average speed over the interval. And then why is it multiplied by 0.2? Well, 0.2 is the time, or the length of the interval. So speed or velocity times time is going to tell us the distance. And then it says, give us an appropriate spreadsheet formula that uses cell D9 to calculate cell D10. So D9 is the total distance from the start. So D10 will also be the total distance 0.2 seconds later. So you add together D9 and C10, the distance fallen in the next 0.2 seconds. And that's your formula. And then finally, you can check this spreadsheet model is given sensible answers for the total distance fallen. Well, I'm running out of time. The bell's just gone and I'm being thrown out of school. So very quickly, you can use S equals UT plus half AT squared. And you can then calculate the cell D11. Oh no, the total distance fallen there, and the answer comes out at 12, S equals 12.557 meters. That's 1 sig fig more than what's over there. I have to go now. Hope this helped. Goodbye.